Welcome to the gravity engine demonstration of lunar transfers and lunar course corrections. The course corrections are a new feature in Gravity Engine 2.0. It's still under development. It's working fairly well, but there's more that needs to be done to make it better. So I'm here in the mini games folder in the scenes directory, and we're going to use this scene called Planet Moon Transfer. And so what we have in the scene is two space stations, a spaceship, and then off in the distance there's a moon. And we're going to transfer to the moon and make a course correction as we go. So there's some new technology in Gravity Engine 2.0 which allows us to do predictions of the future paths of objects, and to do those on an independent thread so that they don't interfere with the frame rate of the program. So to demonstrate some of that, let's just start with opening the console and pausing the scene. The Gravity Engine console is described in a different video, which you'll find in the blog pages at nbodyphysics.com. So here in this scene we have a spaceship, and if we make this console a little bit bigger and look at the console commands, we're going to be looking at these commands for the Orbit MG controller. In particular, what we want to do is first do a patched conic preview, which is to actually make a copy of the current state, determine the patched conic orbit transfer for a particular value of the approach angle lambda, and run a simulation and stop at the point of closest approach and report that closest approach. Now the PCP command runs directly. It does not put itself on a separate thread. There is a version that can do that. But let's say for an approach angle of 74, we'll do a PCP. So it's gone away and done that calculation and determined that for an approach angle of 74 degrees, we will approach at a distance of 3.5. Now that's if the transfer occurs at exactly the time that it's predicted in the maneuver, and because of the time slicing in the numerical integrator, there will be some error associated with when we apply that transfer, and that will result in an error in the approach distance. So to actually go ahead and execute that maneuver, we use the moon transfer command, which is M. We also give it the same approach angle 74, and it imposes that maneuver, and away we go. And if you look at the scene in the background here, we get to the point where the Hohmann transfer to the moon can start for the patch conic transfer, and away we go. So let's first of all just do F2 to keep our view focused on the ship, and then we'll bring the console back up and we'll speed things up a bit, and then you can see that it reported that, oh actually it didn't. So we'll go ahead and zoom until we get to about the midpoint, which is a time of about 150. So we'll pause there at 150. So if we look at these commands, there's also a project the path forward and determine closest approach. So now that we've executed our maneuver, which was supposed to give us an approach of 3.5, we can have a look and see what we're actually on target to approach at. This is just a forward simulation. So this was actually done on a background thread, so it started the calculation and then reported it back. And yeah, there's been kind of a serious error. We're now going to approach at 0.4 instead of 3.5, which is maybe a little closer than we would like, probably closer than the surface of the moon. So there's another command here called Lunar Correction, and what it's going to do is it's going to run a forward simulation as is, figure out the closest approach, so it'll recalculate this 0.4, and then it's going to give a slight increase and a slight decrease to the velocity and run those as simulations and see what the resulting distance is, and then it will do a linear interpolation and come up with a correction that it thinks will achieve this originally recorded target of 3.52 units. So let's go ahead and hit C. It'll start 3 threads. We wait for all 3 threads to finish. It comes up with a slight velocity correction, and the velocity correction says that our approach distance will actually be 7.84. So that's not really what we were looking for. It's better than the 0.4 we were headed for, and this is the part that I need to tune a little bit better. linear interpolation is clearly not the best solution. But in any event, we can now type go and let this run and see how close we actually get and whether we do achieve this 3.84. There is an additional complication, which is we're only checking the approach distance once per frame, and really what we need to be doing is checking it inside the integrator. So that's an improvement I'll be making in the future. So here we go, we're getting close, and it reports that our closest approach is actually 7.85, so pretty much as advertised from the course correction. So that's not a bad thing. We could, of course, have, as we've gotten progressively closer to the moon, done more course corrections, and it will try and steer us back to that 3.84 number. If you're interested in a little bit of the technology under the hood, for example, how to clone a gravity state and evolve it independently, if you look inside the code for the OrbitMG controller that's linked to these console commands, that will lead you on the right path into that code. Essentially, we make a clone of the gravity state and then on an independent thread evolve that gravity state forward. And then after each evolution step, check various things like closest approach and so on. So I think this is a good start on the lunar course correction feature. There's more to do to improve the precision, but I think it provides some useful technology to get better transfers. Thanks for watching.